Hello and welcome to Graphing Quadratics number 6. Today we are going to learn how to write or create equations in standard form for data using what is called quadratic regression. Now, doing linear regression is something that we did in Math 1 using linear regression. So what we do is we have a list of data and we enter that into list 1 and list 2 in our graphing calculators. And then we go and allow the calculator to create the line that best fits the data. So the same thing is true with quadratic regression. We put in our data, which is probably going to be kind of U-shaped, and then we are going to allow technology to create or write a quadratic equation that is going to best estimate that data. So in your graphing calculators, it's, here, it's in the stat menu. When you go into your graphing calculator, you can edit and put information, your data into your list 1 and list 2. Those are X values and Y values. And then we would go back to stat and then to calculate. And in Math 1, we use number 4, which was a linear regression. Because these are quadratics, we would use number 5, which is called a quadratic regression. And we go through this process of putting data into our calculators and then letting our calculator create our equation. And what I'm going to do today is I'm going to show you that number 1, if you are looking at my PDF of the notes, so this is what is available to you, the how-to is for your calculator. Many of you don't have a calculator, and quite frankly, this is one of those things that Desmos does a little, I don't want to say does a better job at, because it's all the same thing, but it's just, it makes it easier. There are less buttons to hit on Desmos. So the online PDF that you have of these notes, you can follow along for your calculator. I am going to show you in this video, dang it, I keep dropping my pen. I am going to show you how to use Desmos to create a quadratic equation. So the calculator and Desmos are going to operate in standard form. So I know that we've just spent, some practice time converting things from standard form into vertex form. However, our technology operates in standard form. So we do not want vertex form while we are doing regression. We want to be using standard form. Okay, so what does standard form look like again? That is y equals ax squared plus bx plus c. So that is what we are going to be coming back to time and time again. Okay, so we use quadratic regression when we are given data. So do you see how we have these points here? So for number 1, I'm just going to take a second and I am going to convert those coordinates into a table of values. Desmos uses a table of values, so instead of doing coordinates like that, I'm just going to set it up in table form, and it'll be much easier to get things into the correct spot. So -4, -3, 0, -2, and 1, 7. So what we're going to do is we are going to put this information into Desmos. So if I just start typing, I'm going to start creating an equation. All right, so I'm going to start with nothing here, and I am going to add not an expression, that's your equation, but I am going to add a table of values. So step number 1, you are going to hit the plus button, and then you are going to select the table of values. And now I'm just going to use my keyboard to put that table of values in like I have it written on my paper. So -4, -3, and then arrow down, 0, -2, and then arrow down, 1, 7. So you can see that I have a scatter plot starting here. If you click on the dots, it will turn your scatter plot on or off. So clearly I want it on. Okay. So now what we're going to do is we're going to come into box 2, and we are going to type in the format that is going to allow Desmos to create our equation for us. So step number 2, and that's in box number 2, this is how we are going to write our equation. We are going to do y1 because it is based off of the table, which is based off of y1 values and x1 values. So y1, and then we are going to do the tilde, which is on the top left corner. So it is the button right before the number 1 button, followed by a x1 squared plus bx1 plus c. So we are going to be writing standard form using x1s and y1s. Okay, so watch how I type it. When I type it, all I have to do is write y1, and it's automatically going to create a little subscript number 1. And then I'm going to hit the shift and the button in front of number 1, which is your tilde. And then AX1, shift 6 to square it, arrow out, plus BX1 plus C. So what I'm doing is I'm telling Desmos that I want it to create a quadratic equation based off of x1s and y1s, so based off of this table of values above. Now what that has done is given me the A, B, and C, so the value that should go here, here, and here, that has given me the A, B, and C values I need to write my equation. So I'm going to write an equation for the quadratic formula. That equation is going to be, and I'm taking my numbers right off of Desmos. So A is 1.75 x squared, plus B is 7.25 x, and then C is a -2. That is your quadratic equation that best matches the data that was provided for you. Now, here is the best thing in the world. On this equation, I know what my vertex is. Look at, I can click on my zeros. I can click on my y-intercept. So once I have created this equation in Desmos, I don't have to go to a different screen. I don't have to retype stuff. It is already there, and I can see all of my key features. I can see where my vertex is located. I can see where my 2 zeros or x-intercepts are located, and I can see where my y-intercept is located. That is pretty powerful. And I didn't have to do a lot of manipulation. So I like Desmos a lot better for regressions, much more so than using the graphing calculator to do this. Okay, so now it's just practice. So now we're going to do it again. So I've been given a list of points, and I'm going to rewrite that in table of values form. So -2, -4, 0, -10, and 3, 7. Now, I haven't done this yet, but this is what I'm secretly hoping. I guess not so secretly hoping. I'm hoping that because this is already based on X1s and Y1s, I'm hoping that I can come up here and I can edit my table of values to match my current data, and it's going to update everything because it's all tied together through X1s and Y1s. So fingers crossed, that is what happens. Ready? I'm going to change that to -2, -4. Looks like we're going to update as we go, which is exactly what I wanted. 0, -10, just changed that point. And then this one is 3, 7. That's it. So you can see how my points were getting moved around and how my equation just got manipulated with the moving around of those points. So these here are my new values. Now, this is not exact. This is the best fit for the data. So I know that you're looking at these decimals going, oh my gosh, Ms. Smith, we need fractions for those. We actually don't, because this is not a perfect quadratic. This is the best quadratic equation that we can get to match this data. So that means that I don't need exact fractions. That means that I can be at peace with just using approximated decimals. So the only thing that you need to decide is how many decimal places do you want to use. The more decimal places you keep, the more accurate your answer is. So I teach AP Calculus, and the standard for AP Calculus is that you keep 3 decimal places. So that is what I will do here. If it's good enough for advanced placement, then it is good enough for us. So y equals A is 1.733, that's my 3 decimal places, x squared, plus B, which is 0.46666. So that third place is going to get rounded to a 7, x minus 10. There it is. There's your equation. And again, super cool that I can get my vertex, I can get my zeros, and it just so happens that my vertex is my y-intercept as well. All right, let's check out number 3. So number 3, I'm going to set it up the exact same way. I'm going to do -3, -2, +3, +10, and +6, -2. And I already have it set up, and I already know that I'm just going to be able to edit my numbers. So -3, -2, and you can watch them here get manipulated and moved around. It's pretty cool to watch. That's going to be a +3, and that's going to be a +10, and that is going to be a +6, and this one is going to be a -2. So I don't have a smile anymore. This is a frown, which means that when I check my A, B, and C, my A should be negative, and it is. This is a frown, and my A is negative. Cool. All right, so that is y equals negative. Do you realize what 0.6666666 is? If you want to be accurate, isn't that just 2/3 x squared? If you use the decimal here, that is perfectly fine. Plus 2x plus 10. There it is, write your equation. There it is, in standard form. Remember, we're going to keep going back to standard form. All right, let's take a look at number 4. Number 4 says, using the table of values, write an equation for the quadratic function in standard form. So they have given us a table of values instead of coordinates, so that's nice. So I'm just going to go back to my table of values here, and I'm just going to start making my edits. So -2, +10. That one is -1, 0. This one is 0. What does that say? -8. I'm going to click down and just keep adding to it. +1, -14, and then +3, -20. So that has been adding in more points, and it is connecting my new quadratic function to those points. So write the equation. Here are my A, B, and C's that I need. So the equation is y equals x squared, right? 1x squared minus 7x, and then a -8. So that is the equation. And then we have some follow-up questions. So what is the vertex of the parabola? Well, I can just go ahead and click. You have to click on the graph. If your table of values is highlighted, that means that it is highlighting your blue dots. I don't have anything on purple. But if you go and you click your purple equation, see how it just got much darker? Now I can see the little gray dots that pop up. Those are on the purple function. So if I click here on my vertex, I know that the vertex is at 3.5, comma, -20.25. And the last question is about the range and the axis of symmetry. Axis of symmetry, it's easy. Remember, it's just x equals the x coordinate of your vertex. So 3.5. And then the range, if I look at my smile, the lowest my smile is going to go is -20.25, and then a smile is going to go up forever. So that is the range. Or if you prefer, y values have to be greater or equal to -20.25. So super easy. We can answer almost all of the follow-up questions just by clicking on the appropriate things on our Desmos graph. Okay, application problems. Guess what? It's all the same stuff. So this table of values, instead of going vertically up and down, it is going horizontally. So who is the top? Are the lengths, are those the x's or the y's? Well, x's always come first. So those are x values, and then the weights are y values. So you can rewrite that, like if you needed to in the margin, you could write that vertically if that helps you keep track of information. If it's no problem for you to just go straight across, then just go ahead and edit. I'm going to fix all of my x's first, and then I'm going to go back through and do all of the y's. So 60, and then 62, and all I'm doing is arrowing down, and it allows me to just rewrite over the tops of those values that are already there. I don't have to delete anything. All right, then I'm going to come over to my y's, and I'm going to do the same thing. So 105, 114, 124, 131, 139, and then 149. All right. So let me scroll back. Let me scroll back over here. So I can't see my graph. So I probably need to zoom this guy out a little bit, and then we will see our data pop up. So here's the data from our graph. So this is sand sharks, their lengths and their weights. And then here is my quadratic formula that has been created based off of this data. All right, So first question says, identify the independent and the dependent variables. So remember that independent, those are always the x values. So our x values represent the length. And we know that the length is going to be in inches. The dependent variable is always y. In this case, that represents the weight of the sand shark, and the units are pounds. So inches and pounds. It says write a quadratic equation to model this relationship. All right, sweet. So I have already done that. I've got y equals, and again, I'm just stealing my values here from Desmos, A, B, and C. Those are not nice, so I'm just going to use 3 decimal places. Negative 0.013 x squared plus 6.0553, so I'm going to leave that as a 5x, and then minus 209.857. Using the equation in part B, predict the weight of the sand shark whose length is 82 inches. All right, so we're going to have some plugging in to do here. So the length being 82 inches, that means an x value of 82 inches. So you have some options. You can use algebra and you can type that 82 into the x value of your equation, which can be done right here in number 3. So you can type in your algebra, or you could just type in your equation that we're working with. So y equals negative 0.013x squared, and then plus 6.055x minus 209.857. And remember, we can look at this table of values. So if I go up to my gear and I say I want to look at number 3 as a table of values, then I can plug in an x value of 82, and that tells me that my y value, that means that the weight is y values, that means that the weight is approximately was that a 219? Or is that a 1? That's a 1. Oh, what am I saying? Where did I get 219 from? That is hold on. I have it written in my notes differently, and I feel like I need to double check. That's not what I want. Gear. How do I get it back to a function? Do I undo? No. Do I do that? No. Ah. Oh, there it goes. Okay, so I just have to back myself out, I guess. I want to make sure that I typed this incorrectly. Negative 0.013x squared, positive 6.055x minus 209.87. Okay, so it is wrong on my PDF note sheet. That's okay. So let me go back to my table of values, and I want to make sure that I have an x value of 82, which means that I have approximately 199.241, and these are pounds. Then D says, using the equation in part B, what is the approximated predicted length of a tiger shark who weighs 300 pounds. So that means that I am looking for a Y value, right? Inches, that was the length, that is X. And here I am looking for a Y value of 300. So let's see, I'm going to come to my graph. Can I drag any points? Can I find points on, that's not what I wanted to do. I am looking for a Y value of 300. So if I zoom in, right, this is my black equation. If I zoom in on 300, I am looking for that point right there. And I can't tell exactly what that is. This is 110, and I want to be as close to 300 as possible. So if that's 300 and that is 110 in the X direction, there's 115. So that is 110. That should be 111, 112, 113, 114, 115. Yep, that matches up. So I'm thinking maybe 110 and a half. Well, how could I get that estimate? Could I try 110 and a half? Oh, look at how close that was. 300, let me widen this up a little bit. 300.4, like I could actually back that off a little bit and I could just keep making some valid guesses. So how about, oh, that is super duper close. It's probably the best estimate that I'm gonna get. So that means that when my Y value is 300, that means that my X value has to be approximately 110.35 what? What are X's? X's are inches. So Desmos is cool because you can go ahead and you can just plug in numbers to find a quick estimate. That is a little quicker and a little more user-friendly than being able to manipulate your calculator like that. Okay, so last question on number 2. Let me get rid of that one. And let me go back to my table of values. So this is actually a great problem to show you this. When you are doing your calculator, when you are dealing with really big numbers like 2005, 2006, if your problem is dealing with time, you are allowed to set your time start whenever you want. You could say that 2005 is time 0, and then time 1, time 2, time 3, time 4, time 5. Or I like to be a little more transparent than that. And I like to, instead of using 2005, I would just call that a time value of 5. That way my numbers aren't going to be ginormous. I'm dealing with more manageable numbers. So if 2005 is 5, then that means that 2006 is a time value of 6, and 7, and 8, and 9, and 10. So if you are dealing with time, you are allowed to reassign your time values. So I'm not going to be using the 2000s for my X's. I'm going to be using 5, 6, 7, 8, 9, and 10. Okay. So let me get those in. I've got 5, 6, 7, 8, 9, and 10. And that is going to correspond to 158, 145, 132, 130, 138, and 142. So let me back this graph out so I can, oh, there it is. Now I can zoom in a little bit better. So there's all my data. See how it's not perfect? That line does not come all the way down to this point. That's okay. This is just giving us the best estimate for the data. That just means that this one is kind of an outlier, if you will. Okay. So step number 1, it says find the independent and dependent variables. Okay. So independent, those are the X values, which in this case represents time, and time is in years. So this is time in years. The dependent is the Y. In this case, Y is represented by P, and that is the average sales price of a house. So Y is represented by P, which is the average sales price of a house in Norfolk, Virginia, in thousands of dollars. So the house isn't $158, it's $158,000. Again, we're trying to make our numbers smaller, so we just have to keep that in mind. Time is in years, that's 2005, and then 158 is actually $158,000. Okay. B says, write a quadratic equation to model this relationship. So I'm going to use my A, B, and C values here. So Y equals 3.0178 is going to round that to an 8, x squared, minus 48.2107 is going to round that 0 to a 1, x, plus 323.857. Using your equation, so I'm going to, in number 3, I'm going to type my equation in. So Y equals 3.018x, square it, minus 48.211x, plus 323.857. All right, so this is my blue equation. Oh, I don't like that. It is blue, but oh well, here's my equation. And I want to know what is the average sales price in the year 2020. So remember, time 2020, that is our X value, and I'm not looking for 2020. I'm looking for a time value of 20, right? If 2010 is a time value of 10, then that means that 2020 is going to be a time value of 20. So I need to look at where X is 20. So let me convert this to a table of values so that I can plug in an X value of 20. So that means that this is the average sales price. So approximately 567, right? Rounding. And this is in thousands of dollars. So approximately $567,000 would be the average sales price in 2020 if we are following this quadratic model here. All right, last question. It says, according to your equation, approximately what year, so that means that we're going to be looking for an X value, do you expect the average sales price to reach $200,000? So that means a Y value of 200, right? Because we're assuming, I mean, we're basing this off of thousands of dollars. So that means that a Y value is going to be 200. So if I look at my graph, I can find a Y value of 200, which is right here. And there's 2 of them. Which one should I pick? Well, here's 10. Actually, let me get a little bit closer in on this. Oh, look at that. I can select a point on that graph. I didn't know that before. I was trying to select a point on the equation that I wrote, but if I went back here, I can actually highlight a point. So this right here, my Y value is close to 200, but that's only 3. So that means in 2003. Well, that is before this graph, this chart started. So that means that I want to come over to this one. I'm going to select that purple graph again, and I am going to plot my point right, well, 199.96, that's probably as close to 200 as I'm going to get. So 12.75. So that means that somewhere in 12, so that means that somewhere in 2012, 0.75 actually means towards the end, right? So this is going to be towards the end of 2012. So not quite 2013, because it was 12.75. So 0.75, that would actually put you 3/4 of the way through the year. So if there's 12 months and you want to go 3/4 of the way through the year, you got that figured out? That's 9 months. So January, February, March, April, May, June, July, August, September. So it's going to be somewhere around September in 2012. Hope you are finding Desmos to be as simple as I think that it is, especially after years and years of using one of these. There's some really cool stuff that can be done on Desmos. All you have to do is type in your quadratic regression in this format, and it will give you everything that you need.